guys, today I'm going to go through atomic structure. Before I get started, make sure you guys like and subscribe and comment down below whatever topic you guys want me to go through next. Okay, here we have our basic structure of an atom. Okay, now let's try to label this. So down here we have the electrons, and these have a charge of -1. Okay, and then in the nucleus you have your protons, okay, and these have a charge of +1 each, and you also have your neutrons, okay, and these have no charge, okay. And here's just a recap of the information. So your proton and your neutrons are in your nucleus, and your electrons are in something called an orbital, but from GCSE you might remember it as they're just in the shells, okay, and you can just think of that for now. The masses of everything, so your proton and your neutron have a mass of 1, and your electron has a mass of 1/1840, so it's really small compared to your proton and your neutron. And then your charges, like we said before, protons +1, neutrons neutral, and electron is -1. Your atomic number is the number of protons you have in the atom, and then your mass number is your the number of protons plus your number of neutrons, okay? So if you were to trying to figure out how to work out the number of neutrons, you just do the big number minus the small number. So in this case 7 minus 3, and then we get 4, okay? And if we look at our diagram here, we can see that we have 4 of the green particles, so we have 4 neutrons. So it lines up with what we worked out here. Here's a question for us to try out. So we know that in magnesium there's 12 protons, right? Because the small number is 12, so that means there's also 12 electrons. But however, we have lost 2, okay? Because we have a +2 charge, so that means we lost 2. So now we have 10 remaining. So the answer is A. Isotopes are atoms with the same number of protons but different number of neutrons. Okay. So, for example here, these two isotopes have the same number of protons, but they have different number of neutrons. Now, the fact that they have the same number of protons, which is 17, is the reason why they're both chlorine. Okay, if they had a different number of protons, they'd be a different element. But they can still have different number of neutrons, right? So that's a really important key fact. The number of protons doesn't really matter to decide what element it is. It's just the number of protons. Now isotopes have similar chemical properties because they have the same electronic structure. So since they both have 11 electrons, they're both going to be those electrons are going to be arranged in the same way, have the same configuration, and the electron configuration is what decides how it reacts, pretty much. So since they both have the same structure, they're both going to react in the same way. They may have slightly varying physical properties because they have different masses. Okay, here's the table for us to try and fill out. So firstly, what I'd fill out is the number of protons. So since they're all carbon, we know that all of them are going to have the same proton number. So if we look at our periodic table, the small number is 6. So we know all of them are going to be 6. And our number of protons and our number of electrons are going to be the same. So 6, 6, 6. Now we do big number minus small number. Now for all of these, the small number is going to be 6, right? Because it's our number of protons. So do 12 minus 6 to get 6. 13 minus 6 to get 7. 14 minus 6 to get 8. Okay. Which atom has 1 more proton and 2 more neutrons than 31p15? So the quickest way to do this, I think, see, okay, so the small number here is 15, right? So that represents the number of protons. So there's 15 protons. Now we want one more, right? So now we have 16 protons. So our new small number is 16. Now it can still be either one of these, right? Because they're all 16. Now we need to look at the mass number. So we have one more proton and two more neutrons, right? Now this big number here, 31, is the number of protons and the number of neutrons, right? So if we add a proton, it's going to go up by 1. If we add two more neutrons, it's going to go up by 2. So we do 31 plus 1 because of this, plus 2 because of this. So now we get 31 plus 1, 32 plus 2, 34. Okay. So now our big number is 34 and our small number is 16. Okay. So now it can be either B or D. Okay. Because they both have the same small number and they both have the same big number. But which of these do we pick? Well, we have to look carefully, right? So when you have 15 protons, your P, okay, the element is phosphor, I think. So the element when you have 16 protons has to be different. And if you look at your periodic table, when you have 16 protons, it would be sulfur. Here's another one to try. Which atom has the smallest number of neutrons? Okay, pause the video and try yourself. Okay, so what I would do first is I'd write the small number in the periodic table, the number of protons. Now the reason for this is they've given us the big number, and to work out the number of neutrons we need to do big number minus small number. So I'm just going to write down the small numbers. And now we do big number minus small number. So 3 minus 1 equals 2, 4 minus 2 equals 2, 5 minus 2 equals 3, 4 minus 3 equals 1. So our smallest number is 1, which is D. Since chlorine has two isotopes, there are two different mass numbers we could use for the periodic table. Instead of just choosing one of them, we work out the average using their masses and their percentage abundance, which is basically just a fancy way of saying how common each isotope is. And this calculation that we do, the answer will be called the relative atomic mass. Okay? So basically, instead of in the periodic table, instead of just choosing either 35 or either 37 for the mass, for the big number, what we do is we work on average. So I'm going to show you guys how scientists work out this average. So we get the big number, the mass number, for each isotope. So in this case, here this is 35, and then we get a percentage for that isotope, for that specific mass. Okay, 75, and then we add all of these up. So then we do the same thing for this compound. So the mass is 37, sorry, this isotope. So the mass is 37, and then we times it by 25, and then we divide the whole thing by 100. And our answer is 35.5, and that's the average, that's the relative atomic mass. So if you look at your periodic table and you look for the mass number of chlorine, you get 35.5, and that's how that was worked out. Okay, here's another exam question for you guys to try. Pause the video and try yourselves. Okay, so I'm just going to do the same thing again. So 24, the mass times the specific percentage. And then divide by 100. And then our answer is 24.3269. So 24.33 to forward the significant figures. Okay, so here's a hard example for you guys to try. So bromine has two isotopes, bromine 79 and bromine 81. The relative atomic mass of bromine 79 is the relative atomic mass of bromine is 79.9. Calculate the percentage of Br79 atoms in a sample of bromine. Okay. Now, to go about this question, you have to think of it logically. So, they're asking you to work out the percentage of 1, so let's call this percentage x, right? Now, the other percentage, we don't know, so we can call that y as well. And the first thing I think of is try and work this out just how you normally do it, right? So, how you go across a normal relative atomic mass question. So 79x times the percentage plus 81y and then we divide it by 100, right? Equals 79.9. So these are a percentage, by the way, if that wasn't made clear. Now, here, the problem is we have two different letters to solve and we only have one equation, right? However, we can make this easier for ourselves because we know one thing, okay? Percentages add up to 100. So we know x plus y must equal to 100. So we can say y equals 100 minus x. Then we can sub that into the equation. So we get 79x plus 81 plus 81, 100 minus x divided by 100 equals 79.9. And now we just need to solve this mathematically. I'm just going to use my calculator to solve it really quickly. Okay, and I get x is equal to 55%. Okay, before we finish off in this video, I've just written down these three definitions that you guys should really remember. I'm going to explain what they mean so that it's just easier for you guys to memorize instead of just memorizing a bunch of text. So the first one, the average mass of one atom compared to 1/12 of the mass of carbon-12. Okay, so the average mass of one atom basically just means what we've done here. Okay, so we've got all the different isotopes and we've worked out an average of each of one atom. Now, when we say compared to 1/12 of the mass of carbon-12, what that really means is basically these atoms are really, really small, so we don't use grams or anything because they're too small. We get like 0.0000001. Okay, it's really, really small numbers. So instead, we just say on a scale where carbon-12 weighs 12. Okay, that basically means one proton has a mass of 1. Okay, so that's what this whole thing means. And then the average mass of one atom is just about the calculation that we did before. The relative molecular mass is the average mass of a molecule compared to 1/12 of the mass of carbon-12. So the average mass of a molecule just basically means back in year 11, when you would work out something like C6H12 and try and figure out the RFM of that, so the mass of that is called the relative molecular mass because it's the mass of a whole molecule. The relative isotopic mass is the mass of an atom of an isotope compared to 1/12 of the mass of one atom of carbon-12. So that basically just means the mass of an individual isotope. So like here, the mass of this isotope is 35, the relative isotopic mass is 35. The relative isotopic mass of this is 37. Okay, so it's the mass of one individual isotope. Okay?